Friends-Global Gardens. Today I'm wondering, what is a scientist? Is it someone in a lab coat using an expensive microscope? Or someone experimenting with fancy test tubes? Or is it wizards and witches with bubbly formulas and smoky chemicals? No, you are already a scientist because you are doing the one thing that makes a scientist a scientist. You ask questions. I wonder how this car works. I wonder what will happen if I drop this egg. Oh, why is the sky blue? There's only one difference between you and the scientists that are sending astronauts to the moon and trying to cure COVID-19. And that is that they are following a very special scientific roadmap. Would you like to see the map? There are 6 steps on this map. 1, 2, 3, 4, 5, 6. And this is what it looks like. It's called the scientific method. The first step, you ask a question. The second step, you do some research. The third step, you make a hypothesis. That's just a fancy word for making a guess. The fourth step, you do the experiment. The fifth step, you make observations. And the sixth and final step is you get a result or a conclusion, which means you get an answer to your original question. It all starts just by asking a question. So now we're going to practice those 6 steps by saying them out loud without using the poster, so that you guys can be like the scientists sending astronauts to the moon. I'm gonna be using a little bit of sign language to help you remember these. First of all, I've been showing you 1, 2, 3, 4, 5, 6. That's sign language. And so we're gonna continue using a little sign language. If you see me do this, it means to read. And I'm gonna do that sign when we say the word research. I'm also going to use the sign which means smart, okay? So let's see if we can practice the 6 steps of the scientific method. First, we ask a question, then we do a little research, which makes us smart so we can make a hypothesis. Then we have fun doing the actual experiment. And while we're doing the experiment, we have to make observations. Then we look at our observations and we have a conclusion. I used one more sign I forgot to tell you. Fun. Because the scientific method and asking questions is a lot of fun. And the fun begins by simply asking a question. That's step number 1. Fun continues through step number 2. Do a little research. Look at a book. Woo, you'd be surprised what you can find. Look at your computer. Type in some stuff. Wow, you're learning. And then it's fun to make a hypothesis, wondering what could happen if...
I don't think the egg will break if I wrap it in this towel.
That's a great hypothesis. Let's have fun doing the actual experiment. And kerplop. Whoa. Next, step number 5, it's fun to make observations. Open it up and reveal, ooh, ooey gooey egg yolk. Wah, wah, wah. Write that stuff down. And how much fun is it to get to step number 6? You got an answer to your question. Fantastic, scientists. So here we go. One more time. First, we ask a question, then we do a little research, which makes us smart so we can make a hypothesis. And then we have fun doing the actual experiment. And while we're doing the experiment, we have to make observations. Then we look at our observations and we have a conclusion. All right, scientists, let's get started. Okay, now it's your turn. Let's try it out. Let's try out the scientific method and see if it actually works. Okay, so first, we're going to ask a question. My question today is inspired by the holiday baking season. And my question is this: how can I make my bread and my rolls the fluffiest and the lightest and the airiest, most delicious things ever? See, I told you scientists don't always wear lab coats. This one's wearing an apron because baking and cooking is a science. Okay, now on to step number 2. Let's see. First we ask a question, then we do a little research! One thing I noticed during my research is that all the recipes for breads and rolls contained one special ingredient. It was yeast. This is what it looks like. I bought this at the grocery store from the baking aisle. Doesn't cost very much and it comes in a small little packet. What's so special about yeast and why is it in all of my recipes for breads and rolls? Time to do a little more research. It turns out yeast is alive. Yeast is a microorganism. Micro means small and organism means living thing. So the yeast is actually a tiny living thing. That's right, we're putting something living inside of our bread and roll recipes. So I guess if it's alive, it is drinking and eating and breathing. But as I take a good look at my yeast, it sure doesn't look like it's eating or drinking or breathing. To me, it looks like that yeast is sound asleep. Well, how can this yeast make my breads and my rolls rise if it's sleeping? I wonder how I can wake it up. Hello, yeast. Wakey, wakey. Hello? Anybody there? Time to wake up, yeast. I better do a little more research. Turns out that my yeast is a lot like another living thing that I have sitting around, a packet of seeds. These seeds also are suspiciously sleeping, and I do actually know the 2 things that I need to wake up these seeds happens to be the same 2 things I need to wake up the yeast. What are those 2 things? A little bit of water and a little bit of warmth. I found out one more kind of funny thing about yeast when I was doing my research. I found out that its favorite food is maybe some of your favorite food too, sugar. And the funny thing is, when the yeast eats sugar, it kind of lets off a little burp. It's just like you or me. Sometimes when we eat, we also let off a little gas and we burp. The little gas that the yeast lets off is called carbon dioxide. And so, if I put a little yeast into my bread recipe and I add a little sugar and I mix it up with the warm water, my yeast is going to start eating the sugar and making little bubbles of carbon dioxide burps, which will in turn make my bread light and airy and fluffy. Whew, that was a lot of research. We learned that yeast is alive, it needs water and warmth to wake it up, and its favorite food is sugar. And when it eats it, it burps a little gas called carbon dioxide. Finally, we can move on to step number 3. First, we ask a question, then we do a little research, which makes us smart so we can make a
hypothesis!
Before making my hypothesis, I like to go back to step number 1 and remember what my question was. I wanted to know how I can make my bread the fluffiest. After all my research, I think that adding a little sugar to my recipe will make my bread fluffiest because it'll give the yeast something to eat that will make it burp out carbon dioxide that will make bubbles, which will make my bread fluffy. Yay! We made it to the fun part. Step number 4. First we ask a question, then we do a little research, which makes us smart so we can make a hypothesis. Then we have fun doing the actual
experiment!
Now, before we have all that fun, we need to do a few preparations. Think of it like you're having a party. Before the party starts, you need to make a grocery list so you have all the supplies ready. And then you also need to make a plan of what's going to happen during the party so that once the party starts, all the fun happens very smoothly. So, before we start the experiment, I'm going to make a list of all the stuff I need. That's called my material list. Then I'm going to make another list that tells me all the steps I need to take during my experiment. That's called my procedure. I'm going to save the actual baking of bread for another time just because we need so many ingredients. But we can still experiment with our ideas with using just a few simple supplies. So I'm going to write down my materials. I'll need balloons and water bottles and yeast and sugar and water. And then I got to think about what I'm going to do first. And what am I going to do second? And then what am I going to do third? And what am I going to do after I label those bottles? I'm going to pour half of that. Yep, got that. Okay. Now I'm going to do, right, add that sugar. Can't forget that. And step number 4, got it. Okay. Time to gather those materials that I had just written down. Makes it so easy having a list. Get some water. Got my yeast, got my bottles, got my balloons. Oh, can't forget, gotta heat up that water. Water and warmth. I remember, I researched. Perfect. Okay, now it's time to start the fun. I have my materials, my water that I microwaved so it's warm, my yeast packet, 2 empty bottles, a Sharpie for labeling, a teaspoon, some sugar, and 2 balloons. Just wait, you'll understand why I have balloons in a second. So now, my materials are ready, let's follow the procedure. Step number 1, heat the water. I did that. Step number 2, add the yeast. Wakey, wakey, yeast. Step number 3, label the bottles. Sharpie. One bottle I will label yeast. And the other bottle I will label sugar. All right, it says step number 4, pour half of the yeast into the bottle labeled yeast. Okay, yeast, going to pour half of this. Perfect. Step number 5, add sugar to the remainder of the yeast. Sugar time. Are you ready to eat, Mr. Yeast? I need 1 teaspoon of sugar for 1 packet of yeast. Adding it here, mixing it up. And step number 6. Add the sugar and yeast mixture to the other bottle labeled sugar. Step number 7 and final step, attach balloons to the top of the bottle. You may be curious why I attached balloons to the tops of the bottles. Well, if we're not going to watch bread rise in the oven, maybe we can watch a balloon rise. After all, the yeast will be eating the sugar and letting off little burps of carbon dioxide gas, and so it will be filling the balloon. I think we're going to wait and we're going to watch. Okay, now we're ready for step number 5. First we asked a question, then we did a little research, which made us smart so we could make a hypothesis. Then we had fun doing the actual experiment. And while we're doing the experiment, we have to make
observations!
Making observations means looking, but also recording. You need to draw pictures or write words or make a chart. Any way that you can put down on paper what's happening, what are you seeing during your experiment. That's because we tend to forget things pretty easily. And I would hate for another scientist to come along and ask me about my sugar and yeast experiment, and all I can say is, I don't know. Instead, I can get out my observations and I can show it to them. I decided to use a simple chart. I just drew a rectangle and then I divided it into 4 parts. I'm going to have 2 columns and 2 rows. Over the first column, I wrote yeast, which represents the bottle that will just have yeast. And over the other column, I wrote sugar, which represents the bottle that will have yeast and sugar in it. And then I came over here and I decided the first row should be labeled 30 minutes, meaning what will they look like after 30 minutes? And the second row is labeled 1 hour, meaning what will the bottles look like after 1 hour? I'll just draw pictures. Here's what they look like right now at the beginning of the experiment. Not much to see here. I've got 30 minutes till I make my first observations. Oh, what am I gonna do with my time? Finally, 30 minutes has passed, and whoa, it looks like the bottle with the sugar and the yeast has changed a lot. I think the yeast is eating the sugar and burping a little bit, inflating it. I better write this down. So I'm gonna draw a picture of the bottle with only yeast in it and its floppy balloon. Then I'm gonna draw the bottle with the sugar and yeast and show its inflated balloon. Wow, this has really changed after just 30 minutes. I wonder what will happen if I give it another 30 minutes. Ugh, I've got more time to kill. I wonder what I should do now. Whoa! After 1 hour, take a look at this. The yeast has been eating so much sugar, it's really inflated the balloon with the carbon dioxide. Wow, I better write this down. So I'm going to draw another bottle showing the yeast balloon, which is still floppy, and the bottle with the yeast and the sugar, which has inflated immensely. Congratulations, we're on our final step. First, we asked a question. Then we did a little research, which made us smart so we could make a hypothesis. Then we had fun doing the actual experiment. While we were doing the experiment, we made observations. And now we can look at those observations and we have a
conclusion!
A conclusion is simply an answer to our question. Wait, question? That was so many steps ago. What was my question again? I wanted to know how I can make my bread the fluffiest. Oh yeah. So let's take a look at the observations that I recorded. It looks like after 30 minutes, the balloon that was filled with only yeast looked pretty floppy. And the balloon that was filled with yeast and sugar looked slightly inflated with carbon dioxide. And then after a whole hour, it looks like the bottle with just yeast in it was still floppy. But the bottle that had the sugar and the yeast in it was a fully inflated balloon. Sugar. And so, in conclusion, the way to make my breads and rolls fluffiest is to add sugar to the recipe. I found an answer to my question. And all of this talk about bread and rolls is starting to make me hungry. So, this time, I'm gonna really bake the bread. Enough of all these balloons and yeast. See you later, scientists. Well, congratulations, scientists. You just mastered the 6 steps of the scientific method. We asked a question, we got an answer. You can do this with any of your questions, with any of these. How does a car work? Ooh, I wonder what will happen if I drop this egg from up here. And again, why is the sky blue? Now, is it easy to get an answer in just 30 minutes like we did during the show? No. Think about the scientists who are trying to discover what made the dinosaurs extinct. They've been doing these 6 steps forever. What about the scientists trying to find the vaccine for COVID-19? They are doing these 6 steps over and over and over. Now, does it mean they're failing because they're not getting a conclusion? No. It means that they're learning something new every time that they do the 6 steps. Then they do them again and again and again. They don't always get a perfect conclusion, and neither will you. But you will always learn something. And if you make sure you write down your observations, that means that somebody else can do your experiment and learn something more. And learn something more and learn something more until we get a perfect conclusion like we did today. Learning simply to add sugar will make fluffy rolls. So, never stop asking questions. And maybe by the time you're watching this video, the scientists who are trying to make that vaccine will have done so. My challenge for you today is to go out there and start asking questions. Big questions, small questions, it doesn't matter. You have a roadmap now to get an answer. Let's remember the roadmap. First, we ask a
question!
Then we do a little
research!
Which makes us smart so we can make a
hypothesis!
Then we have fun doing the actual
experiment.
And while we're doing the experiment, we have to make
observations.
Then we look at our observations and we have a
conclusion.
So go out there and have fun and never stop asking questions. You guys, I tried out the scientific method on something that wasn't sciencey, and it works just as well. I used it to ask the question, how could I make my 8-year-old daughter enjoy her distance learning on her Chromebook a little bit more? Because it sure makes her grumpy. And when she's grumpy, everybody in the house is grumpy. Big sister is grumpy. Mama is grumpy. The dog is grumpy. Even the cat is grumpy. So, first I asked the question, how can I make Zooming for my 8-year-old more enjoyable? So I did a little research and I started thinking about things that bring her happiness. I know that warm, cozy things make her happy, pretty stuff makes her happy, her friends make her happy. And so I made a hypothesis. If I surround her with those things that she loves, maybe her Zooming will be more enjoyable. So I did a little experiment. I gathered a few supplies, a cozy blanket, some pretty flowers, and a friend. And then I did the experiment. While I was doing the experiment, I was making observations of her frown turning upside down. And then it was contagious. Big sister's frown turned upside down, and then Mama's frown turned upside down. Even the dog's frown turned upside down, and the cat was feeling a lot less grumpy. And so I knew I had a conclusion. How can I make my 8-year-old daughter enjoy her distance learning on her Chromebook more? Surround her with things that she loves. Speaking of things that she loves, we've come to the part of our program where it's time to focus on things that you love. It's called appreciations. I want you to take a moment to think about things that bring you joy. Maybe it's a cozy blanket, or maybe it's something pretty. Take a moment to think about something that you feel really thankful is in your life. Okay, fill your body with that joy that you're feeling right now thinking about that thing. And go out for the rest of your day filled with that joy as you start asking questions and following the scientific method. I'll see you next time, scientists. Bye-bye.